Everyone still awake? Doing well? Talk a little more about microsurfacing. Forgot I have to stand in front of this and not wander around. We're going to jump right into it. I could go over the agenda, but we're going to go there anyway. So, how many people are familiar with micro? Some? Okay.
They just don't raise their hands.
Oh, they don't? I see that.
You gotta give them a cone.
All right, I got 4 cones up here, and I'm willing to throw them. So if you fall asleep, you'll get one. If you ask a good question, you'll get one. I can't guarantee my accuracy, but I'm going to try. Microsurfacing. So a thin layer of asphalt emulsion combined with selected aggregate to repair and extend the life of existing roads. Right, so we're extending the life of existing roadways, much like these other surface treatments. Right, we want to improve the surface condition, extend road life, enhance the safety of the road. We're going to talk a lot about improving friction, improving polished roadways, applying something that we don't have to change the curb reveal, a lot of other benefits to microsurfacing. In Pennsylvania, which is fairly unique to Pennsylvania, we use our own nomenclature, right? And in Pennsylvania, we use a type A, a type B, and a rut fill. And we're going to go through the gradations here in a minute, but as you could imagine, type A being fine, right? Type B giving you a little bit more beef to your roadway, a little bit larger aggregate. And then your rut fill, now we're putting that down a little bit thicker. We're going to use a larger, coarser aggregate. This is taken straight from the 408, right? It says use to fill deep 2-inch ruts in a single pass. And I'm going to show you some examples of rut filling. Right, I feel like every contractor stands up and they like have their asterisks, right? Special provision. We're currently, PAAMA, and I alluded to this earlier, trying to update the specifications with PennDOT. It's my understanding that will become less than 2 inches. ISSA's guideline, so the national guideline is 1.5 inches for microsurfacing. And in some cases, depending on return to traffic time and other problems that could arise, I don't know that that's the best use of microsurfacing, especially as those ruts change in size, change in width, and the pavement condition underneath, right? So the rut fill, to me, is always a little bit of a moving target, but 2 inches is aggressive for microsurfacing. So as we look at the gradation chart for type A, 9.5 millimeter, at least 100% passing at 9.5. You can retain some at the number 4 sieve. For a type B, which is, I'll go back to the District 3 presentation from this morning, commonly used as the first layer, right? So we're putting that down first. That's a 9.5 top end, 9.5 millimeter. As you go down through these gradations, you'll notice that the importance of having some finer aggregate, specifically the number 200 sieve. As we've talked about surface treatments in terms of chip seals, right? We want to exclude those. We don't want fines in a chip seal. We want clean cubical aggregate. As we start to introduce ultra thin bonded wearing course, microsurfacings, those fines become important at the right gradation. Our top end aggregates determine the pounds per square yardage that we can start to put down, right? So as you screed things off, the larger the aggregate, the thicker our pass can get. but only to a certain point, right? We are not building strength in terms of a hot mix overlay with a microsurfacing. We're extending the life of a currently in place road. Our rut fill, you'll notice we're allowing a little bit more 9.5 millimeter. We're allowing a little bit more in there, and then more coarser aggregate down through. Microsurfacing. When we're assessing a roadway, and we'll get into some of those assessments, we're looking for polished roadways, oxidation, certain raveling, right? And we're trying to stop that in its place before it gets too far gone. Another benefit of microsurfacing is going over a bleeding road. We can start to trap some of the softer asphalt. Say we've chip sealed a road for the last 25 years, and we've put soft, flexible asphalt in place, right? And our aggregate from the chip seals are starting to drop down in from hot weather, from increased traffic volumes. Maybe the type of traffic has changed over the years. A lot of our roads, specifically in Pennsylvania and other Northeast states, have been chip sealed for a long, long time, right? And so we've added softer asphalt blends over time, oftentimes at different application rates, right? And we start to see that flushing coming to the top, sometimes bleeding on hot days, right? A microsurface can start to lock some of that in so that it can't continue to rise through it. So as we alluded to earlier, we're looking to increase skid resistance, improve the color contrast between the pavement and the striping. Right, so an oxidized pavement oftentimes turns gray, right? Very gray. We start to lose our color contrast. It's hard to drive at night. It's hard to drive at certain times. Maybe we have, on a chip sealed roadway, we have very flushed pavement in the wheel pass, right? And then grayer pavement where the aggregates, or depending on your color of aggregate, in different areas. It's hard to retain paint on some of those types of roadways. We're trying to seal the roadway just like these other treatments, right? We're trying to put a stopgap in from the top down so that water can't penetrate down through. We can re-oxidize the pavement underneath by adding a little bit more asphalt to it, right? So we're giving life back not only to the top of the pavement, but also the pavement that we're going over. We're maintaining drainage patterns and curb reveal. So if we have a roadway that's currently in shape, starting to ravel a little bit, maybe it's oxidizing, flushing, but ultimately we still have slope, right? We have drainage that's just been completed, installed, curbs, depending on where this is. We can't afford to put a 2-inch lift, 1.5-inch lift over it. We don't want to really screed anything too high or put things in at a different width. A microsurface goes in 1/2 inch, 3/4 of an inch at most, right? And we're not changing any of that. Restoring the road profile, right? So in terms of rutting, in terms of minor slope changes, drop-offs, we can start to bring those back up. When we talk about those things, it's important to note that we want to catch them before they're too far gone, right? We're not letting this roadway truly rut to 2+ inches all across the span of it. We're not trying to shim, right? We're not trying to true and level in terms of a hot mix characterization when we talk about restoring the road profile. We're using microsurfacing before it gets too bad. Microsurfacing is also resistant to rutting and shoving, right? So once it's in place, now the curing process needs to happen for that. So when we talk about rut filling, we're not putting it at 2 inches and then returning traffic immediately with 18-wheelers over those 2-inch depths, right? And expecting this thing not to start to belly out. This is also why we start to pair microsurfacing with itself in terms of 2-lift applications. When we go through the candidate selection process, we want to look at the current surface, current condition of the road, right? So we're looking at potholes, types of cracks. We've talked a lot about working cracks versus non-working cracks, longitudinal versus transverse cracks. What types of cracks are we looking at and what's causing them, right? Microsurfacing, again, is a surface treatment. If this road is starting from the bottom up or failing from the bottom up, microsurfacing is not the answer, right? Nor is chip seal or other surface treating applications. We're talking about a structure that we're trying to seal from the top down. Type of traffic, amount of traffic, right? Age of the existing pavements, different weather conditions, environmental impacts. If a pavement is displaying structural distress, or it currently has rutting, deep rutting, shoving, and rutting that's currently happening, right? If this rutting is getting worse annually versus it's reached its depth, we have another issue at hand that microsurfacing cannot treat, cannot solve. So when we look at candidates, we're looking for these types of things in order to rule out or rule in microsurfacing. Going through the selection process, I think involves a myriad of people, right? And I think that this group is interesting and exciting to me to see get together because it joins those forces. You have people in the field, you have design engineers, we have different office staff, we have maintenance staff, a lot of different people in the room, and that's exciting to me to see everyone kind of learning the same thing, right? Because everyone plays a different role in designing. And in my experience, getting those people in the same room and sharing those opinions has led to success versus being fragmented. We only have this much money and this is what we're going to do to this road. And then we go do it. And then the maintenance staff is bitching because it failed, right? And then everyone else is left holding the bag to try to repair it. Story old as time. I don't know the solution, but I have a feeling that this is a good step in the right direction. Right, so as we go out, we want to do our initial assessment. Right? Conduct a visual inspection of the roadway. Identify the signs of surface distress, cracking, potholes, raveling. What's causing that? Is it the age of the pavement? Is it a base failure? Is it a drainage issue? Right, and talk through those things. As we come back to the office, we're doing a little bit of data collection. What's the type of traffic, the amount of traffic, and the road usage patterns? Are we beating it up all day? Is it a rush hour problem? And then not only that, but what has been done to this road annually, right? Or by the decade? Have we milled and filled this road in the past 10 or 15 years, 20 years? Have we applied 30 years worth of chip seal to it? Has it been crack sealed? When was it crack sealed? Under what spec was it crack sealed? Right, so we have a whole list of items that we want to know the history about the roadway. And that can play into what we prescribe to the road, prescribe the treatment. Right, and this selection process to me is really important for any choice that you have. Right, truly understanding what is going on with this road so that we can choose the right thing. It may or may not be micro, right? It may or may not be an ultra thin bonded wearing course, a chip seal. It may or may not be a hot mix overlay. We might have to FDR it, cold in place recycle it. There's a whole bunch of things, but we can't truly understand what to give it if we don't understand the history and what's going on with it now. And road uses have changed. Road volumes have changed. Having that data is important. Assess the pavement structure, existing surface material to determine the suitability for micro. So when we look at concrete versus asphalt overlays, the amount of polish going on the road, there's reasons that we may or may not use a tack coat prior to the application of microsurfacing. There's reasons that we may use a type B versus a type A. Right? So understanding that. Then evaluating the existing surface for skid resistance and other safety factors. So what are we trying to achieve? Are we trying to achieve cracking? Are we trying to get ahead of the curve and this is a 5 to 7 year old pavement that we're trying to extend the life on? Or are we using it as a stopgap treatment? Our prioritization of our road use as well is important as well. We want quick return to traffic, which microsurfacing allows. However, while it's under an hour, we can gain ground with microsurfacing. It goes fairly quickly, right? So in an hour, you could be several miles down the road, hopefully. What our traffic patterns are, what the public's expectation is of microsurfacing, right? As this begins to cure and set, we cannot allow traffic on it until it is set, right? So we're not rolling, and then if someone drives across it or into the zone, they don't necessarily hurt it. In microsurfacing's case, you will see problems with the mat, right? So that whole area has to be shut down for that amount of time. Understanding that. And proper communication both with inspection staff, ACEs on the job, public, and our own forces that are out there. So whether that's traffic control, our support trucks that are coming in and out of the zone, all of that is super important, and understanding what our limitations are. Microsurfacing's, it is visually nice, right? It's black, it looks like pavement. But it has its own limitations. We can't put it on that thick. So we've had a lot of success in combining microsurfacing with a lot of other treatments. Specifically speaking, crack seal is very common, right? Very common. We go out, you crack seal anything larger than a 1/4 inch typically. Terry alluded to using a squeegee over that so that we can come over and not have our screed or our mat catch on the microsurface, or so that we can stop any reflective crack seal from shining up through. We can start to rut fill, right? So we can put a rut fill box at a certain width in the wheel paths, bring that up to level, and then microsurface over our rut fill. Putting two combinations of microsurface is probably the most common practice of microsurfacing, right? So we want to put it down somewhere in that 20-pound range twice. And we can start to do that. We leave a little bit on the edge, then we overlap it a little more, helps with drainage, right? But also, that's where we start to see the benefits of microsurfacing. When we combine it with a chip seal, like is going to happen in District 4, right? Regardless of the type of chip seal, we improve rideability, we improve reflective cracking, all of these things stop. But at the end of the day, the traveling public sees a paved roadway, right? The aesthetic of microsurfacing, black, bright black, long lines. That's, to the driving public, they like that. Scrub seal, right? So similar to that of a cape seal, scrub seal, microsurface. One of the things that I left off of this presentation is the addition of microsurfacing or slurry surfacing as an inner layer between hot mix. So a lot of times on a roadway, if we're looking at a hot mix overlay and we have a polished road, we don't have anything for that layer to grab onto. Right? We can put a microsurface or a slurry surface over that roadway and then come back. We have it sealed now. We can come back and put our HMA over that. So that has been fairly popular in the recent years. The process. Quality aggregate, always crushed, granite, slag, limestone. Right? We want it to be dense. We don't want too much water absorption in our, you'll never limit it totally, but the less that we have, the higher quality, dense aggregate, always crushed, mixed with an asphalt emulsion. Right? So like cationic, quick set, polymer modified emulsion. Mineral filler could be Portland cement, hydrated lime, limestone dust. One of the common misconceptions is that microsurfacing uses Portland cement, so then it's therefore brittle. Portland cement, hydrated lime, limestone dust are used as fines in the mix in order to activate and control your brake, right? In order to control how fast that brakes. Ideally, on a perfect day, you're going down the road, it's coming out of your pug mill, through your screed, you're laying a mat down, and it's brown, and you can watch the black chase you down the road, right? It's braking chemically on the roadway. The amount, and you're judging from your job mix formula, of mineral filler can determine that. Too much of it, too little of it can change the speed at which it brakes. As can your ratio of asphalt emulsion, aggregate, all of that due diligence is needed beforehand. The amount of water. So quality control method, you should be contractors taking the amount of water that's in the aggregate pile, right? You should know how much water is in that aggregate pile and will determine how much water you would need off of your paver in your mix. And then your additive. Typically speaking, additive may or may not be used. It's used on an as-needed basis for the contractor. A lot of times you may see climate change throughout the day. We start off, it's a cool, overcast morning, and by the time you hit 2 p.m., you're out in the middle of the interstate, it's 95 degrees, right? And that chemical reaction may or may not happen at the same time or in the same climate, right? So we can start to slow or speed up our reaction time as the climate changes throughout the day. Our application sequence. Calibrate and set the paver for the job mix formula as determined by the mix design process, right? So in the 408, there's a mix design process. There's also different standards of how we mix design, the tests that we run. And you're going to get asphalt content. You're going to get amount of type of emulsion, amount of emulsifier or chemical in your emulsion. All of these different things are going to be told to us. And then once we get out in the field, we need to calibrate so that we can meet those standards of the job mix formula. Test strip, by PennDOT standard, a test strip is required. And so we're going to go out on the road and pull this 100-foot test strip and verify that, one, the equipment's ready, right? But two, our microsurfacing is braking and our return to traffic time is where we want it to be. Right? The spec is 60 minutes or less. And that's kind of a fluid, usually 60 minutes or less as that communication between the ACE or the inspector is talking about and seeing what we're working with. we want to make sure that our pavement's prepared, right? Our existing pavement needs to be cleaned, as clean as possible. We want it dry. We want to know exactly what we're putting it over, and we want that to be uniform from start to finish. In other words, leaves, debris, things in the way all need to be gone with a pickup sweeper or some type of large sweeper, as well as blower units, anything else that's necessary to clean that roadway. We're going to apply the micro and open back up to traffic, like I said, within 60 minutes. Microsurfacing, for those of you that aren't familiar, is done with a stockpile, an aggregate stockpile in a yard that's somewhere near the job, hopefully. And all of the aggregate is put through a screening plant. And so we need to make sure that this aggregate, as it's gotten maybe wet or changed over time as it's been sitting there, isn't bridging or clumping, right? So we're going to put it through a screening plant prior to loading into our support trucks. In this picture, you'll notice there's a loader behind. I have to stand up here. Let's put it at my screen. So there's a loader behind the screening plant. It is loading into a support unit. And so the support units could be fixed body trucks. They could also be flowboy type units. They're belt driven, V bottom, and typically have a water and an emulsion tank on either side of them. So in this case, you can kind of see the very back. You can see where the V-bottom belt drive, where the aggregate is loaded. And then on either side of that is where the emulsion and the water would be loaded onto the vessel as well. So this is a continuous paver out on the road. This paver holds its own certain quantity of aggregate, certain quantity of asphalt emulsion, a certain quantity of water, and you'll see on top, that's the Portland cement or fly ash, whatever this contractor is using, on top in bags. It goes into the back of the paver. Before the screed is a pug mill, right? So this is being by computer, it's being ratioed into the pug mill. The pug mill is turning, right, and mixing our emulsion, our water, our cement, our additive, and our aggregate into a slurry micro surface. It comes out, it's augered out to the width of the screed, okay, and put down. There's multiple screed setups. Commonly, there's a screed strike or a steel strike off, and some contractors use a burlap in order to give the finish a textured look. Questions about the process for anyone that's not familiar with it, or that no one wants a cone whipped at them? Come on. So in this picture, this is an example of rut filling, right? So we've used a rut fill box to go over the wheel path specifically. You can just pick somebody, Scott. This looks to be about a 6-foot pass, right? So we've brought this up to level, outside center, and then center to outside. And now we can come back over and apply the same uniform 20-pound lift from skip line to outside line. Here you'll see fresh microsurfacing on the left-hand side, right? And probably yesterday's microsurface on the right-hand side, right? And you can see a little bit of the brown, right, emulsion look where this hasn't broken completely yet, right? And it hasn't cured out. On the right-hand side where the traffic is driving, black. And as you can imagine, right, one of the downfalls of micro is that this is, on the left-hand side, that's wet. Right? So if a car drives through it, we put traffic over that, it is going to leave marks in our mat and probably get on the vehicle a little bit and not make someone too thrilled. So traffic control is certainly a concern, or needs to be something that's addressed prior in planning. But also understanding our limitations in length of the zone, types of zones that we set up for our paving plan. And when we talk about expectations and limitations, Terry had the slide up of pavement condition earlier and when to prescribe these treatments. Right? So we're in a B to C range. B would be great. And I think all of us could agree that if we were putting microsurfacing over 8 to 10-year-old, or not 5 to 7-year-old hot mix, man, we're doing something right, because that means we don't have crappy roads elsewhere in our district that we're trying to appease the public with. And that's the goal. We're probably most commonly seeing somewhere in that B to C range, right? So our life expectancy of micro in that range is somewhere in the 6 to 8 year range. We do commonly see micro used as a 4 to 6 year treatment, right? In that stopgap range where our budget says we're limited, but the amount of calls that we're receiving or the failure on this road, we need to do something with it quickly so that it doesn't blow apart all the way, right? Where we're full reconstruction. So somewhere in that B to C range is where we most commonly see micro prescribed. Knowing the expectations and limitations of it is important, right? So if we're prescribing a microsurface to a C road, we are not going to get 10 years out of it. And understanding that of what that roadway is, how we've prepared that road, meaning crack sealing, maybe we've used a combination treatment with it, all of those things help, right? But ultimately that road has seen better days, right? And we're trying to get a surface over it. It is not an ideal candidate. Not to say that it's a bad candidate. It's just that we're not going to get that 8 to 10 years out of it because it has seen some weathering over time. That's all I got. Questions? Yeah.
What you do doing just a simple crack seal and microsurfacing process, what's the average depth of microsurfacing?
20 pounds is usually about a half inch.
Okay.
So
That'll be just in the single pass?
single pass, yep. I'm gonna hit the chandelier. I'll come over in a minute. Who else has something? Yeah.
Thoughts on removal of paint lines prior to microing or not?
Yes. Epoxy, yes. Waterborne, not necessary.
Is there a certain point that the age of the epoxy you go over not to rivet? It's now 4 or 5 years. Lose it now.
I wish I could say yes, because removing epoxy is a pain in the butt. But I wouldn't stand up here and recommend that, no. Good?